Good morning, everybody. Today I will discuss the continuation of application of T distribution. T test for difference of mean or population variance of a noun. Suppose we want to test if two samples x1, x2, so on xn and y1, y2, so on yn2 of sizes n1 and n2 have been drawn from two normal population with mu x and mu y under the null hypothesis. The samples have, have been drawn from with means mu x and mu y and under the assumptions that population variance are equal. Sigma x square is equal to sigma y square, that is equal to sigma square say. Therefore, modulus of t is equal to modulus of x bar minus y bar minus of mu x minus mu y divided by s into square root of 1 upon n1 plus 1 upon n2 follows t n1 plus n2 minus 2 degrees of freedom. When s square is an unbiased estimate of the population variance, sigma square, that is expectation of x square, is equal to sigma square. It follows t distribution with n1 plus n2 minus 2 degrees of freedom by comparing the calculated value of t with tabulated value of t for n1 plus n2 minus 2 degrees of freedom and at certain level of significance. If t calculated value less than t table value, then h0 is accepted. Otherwise, if t calculated value greater than table value, then h0 is rejected. Next application is pair t test for difference of means. In the t test for difference of means of the two samples are independent at the same. Sometimes the sample may be dependent in pairs. Let us consider a particular situations. 1. The sample sizes are equal. 2. Sample observations x1, x2, so on xn and y1, y2, so on yn are not completely independent, but they are dependent is in pairs. Now the problems is to test the sample means differ significantly or not. Therefore, under null hypothesis such that it is h0 is equal to mu x is equal to mu y. Suppose we want to test the efficiency of training in a particular examination for test. Let x1 denote the observations before training and y1 denote the observations after training. Let di is equal to xi minus yi denote the difference between the observations for the ith unit. Now h0 may be written as, that is h0 such that mu x is equal to mu y. In this case, xi minus y are independent in pairs. Now we apply pair t test, that is the mean of before training and after training are same against h1 such that mu x not is equal to mu y, that is mean of before training and after training, and difference under the null hypothesis t is given by t is equal to d bar upon s divided by square root of n follows t n minus 1 degrees of freedom, where d bar is equal to summation di divided by n, where n is number of paired observations, that is s square is equal to 1 upon n minus 1 summation I is equal to 1 to n bracket di minus d bar whole square. The above statistics follows n minus 1 degrees of freedom by comparing the calculated value of t with tabulated value of t for n minus 1 degrees of freedom at certain level of significance, that is if t calculated value is less than t table value, h0 is accepted. If t calculated value greater than t table value, h0 is rejected. Thank you.